Hi and welcome back. Today we are going to go over our homework tutorial for assignment number 2. Assignment number 2 is all about practicing how to use the nautical almanac. And in the site reduction form, there is a whole nautical almanac section. So we are going to get very familiar with flipping back and forth through all these pages of the nautical almanac. So let's get started. Alright, so this is an example of the site reduction form that I have for you. It's my version, but you can get all sorts of different versions online. This section right here, or all the green section, is going to be in the nautical almanac. But today we're just going to practice GHA all the way to LHA and declination to the declination of the time. So we're just going to practice this section right here. I'm going to zoom in so you can see my book, so I'm not going to use the site reduction form. I'm just going to write it out so you can see it while I'm zoomed in. But feel more than happy if you guys just 1, 2, 3, 4 and just did it on a site reduction sheet. That way you don't have to rewrite it every time. Or you could do it straight on the paper itself too. So, let's get started. Okay, so let's get started on number 1. We have a date of February 21st at a GMT time of 0600, and we are observing the sun. We have a DR Latin long, and they're asking what GHA, LHA, and declination are. So, again, you can use your site reduction form, but I'm just writing it out so you can see both pages here. So we want to find our date, and I know this is in GMT, so everything in this book is in GMT time. So they told me that was GMT, I don't have to convert it. So I'm going to go to 0600 for the sun. So I have the sun, GHA, and declination for 0600 on February 21st. So I can write 266 degrees, 34.8, and south 10 degrees, 44.4 minutes. So that is my GHA and declination that I just wrote from the almanac. Now in this case, our time is on the top of the hour, and we have no additional minutes and seconds. It's 0600 even. So we don't have any minutes and seconds. So our GHA is the same. And we have a DR longitude. So our DR longitude is 162.25.0 east. Because it's east, we're going to be adding. So we're going to add 0.895, so 59.8 minutes, and then we're going to add this to 824. So we have 428.59 minutes. 428 isn't a GHA we can use. So we are going to subtract 360 from 428, and we get 068 degrees, 59.8 minutes. So this is our LHA. And our declination, again, we have no correction because there's no more minutes and seconds. So we have south 10 degrees, 44.4 minutes as our declination. So that is number 1. Let's do number 2. Alright, so on number 2, we are on January 23rd at 18:15. And we are observing the sun. And we're going to fill out our site reduction form. So we need to find January 23rd, and then this is the 23rd, or 22nd, so this one's the 23rd, the Thursday, and they told us the 1800 was GMT, so we're going to find 18, so here we have our 18, and we're going to write in those numbers, 7 degrees, 3.5 minutes, and then we have south, 9 degrees, 26.6 minutes. Now on this one, because we do have minutes and seconds, we also want to make a note of a couple more things for declination. Is it increasing or decreasing from 1800 to 1900? It would be decreasing. So we had the 26.6, and then we have 26.0, 25.4, etc., etc. So we're going to be subtracting our correction, whatever that correction may be. And then to get that correction, we have to have the little d. That's going to be down here at the bottom. So we're just going to follow it down. For all 3 days, we use the little d correction right there. So we're going to use 0.6 as our little d. So now that we have everything we need from the date page, we can flip over to the minutes and seconds page. So let's do that. So here are increments, our minutes and seconds, and we need to find 15s because we are at 1815. So here's 15 minutes. So we are at 1815 with 0 seconds. So we're going to use the top here. So for the sun, again we observed the sun. So our additional minutes that we add, or additional correction we add for 15 minutes is going to be 3 degrees, 45.0 minutes. So that's our minutes and seconds. And while we're still on the page, we're going to go to the V and D section. And there we have written down that our D was 0.6. So V or D, we find 0.6, and then we get our correction. So our correction would be 0.2. So we are subtracting 0.2 on that one. So now we can just fill in our site reduction form. We're always adding our minutes and seconds. So we have 3.5 plus 45. Degrees. Our DR longitude is 125, 39.3 west. So we are going to be subtracting that. And we can't subtract 125 from 90, so we have to add 360 to that 90. So 90 plus 360 gives us 450. Okay, so now we can do our subtraction. 48.5 minus 39.3 equals 09.2, and 450 minus 125 gives us 325. So we have an LHA of 32509.2 minutes. And for declination, our correction is 0.2. So we have a south declination, 19 degrees, 26.4 minutes as our declination. And that's it for number 2. Okay, so number 3, our date is April 2nd, and we have a time of 12:44:30. So we have hours, minutes, and seconds, and it's still in GMT. Our body that we are observing is Spica. It's a star. So in this case, we need to get GHA of Aries, then apply our SHA to get LHA. So, we are going to find April 2nd. So we have March 31st, April 1st, and 2nd. So on the 2nd, again at the top here, we have Aries, Venus, stars, Venus, Mars, Jupiter, Saturn, and then the stars. So we're going to get our GHA of Aries is our first thing. So we are going to use my little card, and our time is 12:44. So our GHA of Aries at 12:44 is, or at 1200, is going to be 011 degrees 17.4 minutes, and that's our GHA of Aries. We also want to note on this page our star. So our star, we have alphabetical order. It's one of our 57 navigation stars. So under our stars, we have the name of the star, the SHA, and the declination. So our SHA of the star is going to be 158.26.0, and their declination is going to be south 11 16.0 minutes. Again, that's right under Spica, under the April 2nd. They will be the same SHA and declination for all 3 days. Okay, so now we need to get our minutes and seconds and apply those to get our LHA. So we'll go to minutes and seconds. And we are looking for 44. Okay, so here's our 44 minutes, and we have 44 minutes 30 seconds. So we're going to go down to 30 seconds. So we have 44 minutes 30 seconds, and now we're looking under the correction for Aries, not for the sun. We're looking under Aries. So my minutes and seconds are going to be 11 degrees, 09.3 minutes. And that's all we need. Now we can get our calculator. And we always add our minutes and seconds. So we have 17.4 plus 9.3 gives us 26.7. And then we have 22 degrees. And then we always add our SHA. So your GHA plus your SHA gives you your GHA of the GHA of Aries plus your SHA of the star gives you your GHA of the star. So we have 26.7 plus another 26 gives us 52.7, and then gives us a GHA of 18052.7. So now we're going to apply our longitude. Our DR longitude is 107 degrees 32.0 west. So it's west, we are going to subtract. So now we have 52.7 minus 32 gives us 20.7. And then we also have 180 minus 107 gives me 0.73. and that is our LHA, and our declination we already have. It doesn't need a correction because it's a star. And that's number 3. Alright, so on number 4, we are talking about the moon. It is July 4th. We have a time of 8:20:15, and we are observing the moon's lower limb. So, we have hours, minutes, and seconds, and we are in the moon section of our daily pages here. So we're looking for July 4th, GMT time 0800, and we're under moon. So July 4th is the very bottom one here, and our GMT is 8. So we're looking at the 800, and we're going over to the moon category for GHA. So GHA is going to be 130 degrees, 47.2 minutes. And then we have minutes and seconds, but we also need to mark down this V correction. So V is going to be 5.8. And then we're going to be adding that. And then for declination, we need to write our declination is south, 23 degrees, 40.3 minutes. Our little d, we don't have to go down to the bottom of the page like we did for sun. It's going to be right next to it. So we have 2.7 for our little d. And then is that increasing or decreasing? That's going to be increasing. So we're adding whatever the correction is. And then that last one, HP, is for the sextant corrections when we get to our sextant, and that's going to be next week. So we would make a note of that, but not for this particular part of the site reduction form. So now we go to our minutes and seconds corrections. So we are at 8:20:15. So we're looking for 8:20. So here's our 20 minutes, and then we have our minutes and seconds corrections for the moon, and we're looking at 20:15. So 20 minutes, 15 seconds, and we have a minutes and seconds correction of 4 degrees, 49.9 minutes. And then we're going to use our V and D section here. So our V, our little v, was 5.8. So we need to find 5.8, which is all the way down here at the bottom. So we have 5.8. Our correction would be 2.0 minutes. So it's 2.0 minutes. And then we also have a D correction for our declination of 2.7. So we need to find 2.7. Here is going to be 0.9. 0.9. So now we can use our calculator and add up our numbers. We have 47.2 plus is 99.1, but we can't have 99.1, so we're going to subtract 60, and we get 39.1, carrying the 1. So now we have So we have 135 at 39 minutes north, and our DR longitude is west, so we're going to be subtracting So we have our LHA of the moon of 04823.1 minutes. Declination, we are going to be adding that 0.9. So we have 40.3 plus 0.9 gives us 41.223, and that is that. So that is our site reduction form for the moon. So it's going to be a little bit different than the star, a little bit different than the sun. Okay, so on number 5, we have a date of May 23rd at a time of 10:08:42, and we are observing the sun. Okay, so we want to get our information. I'm on May 23rd. Alright, so we're on May 23rd. We have a time of 10:08:42, and we are observing the sun. Here's our site reduction form, so we're just going to plug in our information. We have the 23rd at the bottom, and we're looking for the sun at 10. So here I have Alright, now we always want to check and see if we're increasing or decreasing. We'll be increasing. And our declination, little d, is going to be 0.5. Now we can go to the hours and minutes. We're looking for 8. So we have 10:08:42. So we're in the 8-minute, and now we're looking for 42 seconds. So that's going to be down here. Can you see those? Yes. Okay. So our 42 seconds and we're looking at the sun. So our correction is 2 degrees, 10.5. And then our little d was 0.5. So we are going to use our correction of 0.1. Now we plug in our numbers. Our estimated longitude you're going to be adding, because it is east. So we'll be adding our longitude. $97.8, we have to subtract 60. Carrying the 1. Gives us 435. Again, 435 isn't a number on our circle, so we have to subtract 360. And the rest is 0.75. So that is our LHA. On declination, we are adding the 0.1. So we have north 20 degrees, 42.3 north. And that is our number 5. Okay, number 6, we have a date of June 23rd at a time of 15:54:19. The body we are observing is the sun, so we can get our information here. We are on June 23rd. June 23rd, GMT time is 1500 some change, so we're going to have a GHA of 44 degrees, 24.4 minutes, and a declination of north, 23 degrees, 24.7 minutes. So again, here, it didn't say the 23, but 23 is up here, so we followed it on the way down. So we're at north 23 degrees, 24.7. To see if we're increasing or decreasing, we will be decreasing. And we follow the bottom to have our little d of 0.1. Okay. Now we can go to the minutes and seconds page. Alright, so we're in the 54 minutes. And we are at 54:19. So here's our 54:19. We're the sun. So we're going to be at 13 degrees, 34.8. And then our little d was 0.1. So we have 0.1. Our correction will be 0.1. And now we plug in our numbers. Our DR longitude for number 6. We're going to be subtracting. We can't subtract 59 or 119 from 57, so we have to add 360 to it, and we get 417. Okay, so 59.2. So we're left with 298 and 21 minutes for our LHA. Declination, we are subtracting 0.1, so we have 24.6, north, 23 degrees. And that's number 6. Okay, on number 7, our date is September 30th, September 30th, and we have a time of 18:21:56, and the body we are observing is Jupiter. So Jupiter, this symbol for Jupiter, something like that, fancy for. Again, you don't have to use those, but so Jupiter is going to be on the left side pages with our 4 navigational planets. We have Venus, Mars, Jupiter, and Saturn. So under Jupiter, we have our GHA and our declination. So we have a GMT time for September 30th. Jupiter is going to be 3:54 degrees, 28.3 minutes. For my declination of Jupiter, I have south, 22 degrees, 40.0 minutes. My next one is the same, so probably neither, but my my correction at the bottom is 0.1. So we'll see what 0.1 give us, probably 0. If I keep going, I'll be subtracting, so I will put a little subtraction sign there, but it's going to be the same. Okay, so now we can go to our minutes and seconds. We are at 21:18:21:56. So we're at 21 minutes, looking for our 56. Down here, and we are under sun and planets. So it's the first column. So our minutes and seconds will be 5 degrees, 29.0. That's here, 5 degrees, 29.0 for our 56 seconds. And then our 0.1 gives us a 0 correction. So for that guy. We have south, 22:40 for our destination. Now for our GHA, we need to calculate. We have a GHA of 35557.3. Our longitude is west, so we're going to be subtracting. So we have our 57.3 minus 18.3. So we have an LHA of 202.39.0 and our declination of 22:40 minutes south. And that is number 7. Alright, on number 8, we have a date of October 28th, and the body we're observing is the sun. They gave us a chronometer time and a chronometer error. So now we have to convert our time into GMT. So we're going back to practicing those time calculations. So they told us our zone time was 0836, and they told us our zone description was +3. So roughly speaking, our GMT is 11:36. Now our chronometer reads 11, so we know our chronometer isn't in the 2300 hours, it is the 11. So we can keep it at 11:35:16, and we have a chronometer error of 1 minute and 4 seconds slow. If it's slow, we need to add it. So I'll get my GMT time of 20:36:11, and that is October 28th. So now, when I am observing the sun, I can see the sun, October 28th, at top of the hour is 11 is 3. And our declination so we have the 1320.9. Now our little d at the bottom, and we have 0.8. Forgot to check here if we are adding or subtracting. So from 11 to 12, we are going to be adding. Okay. So let's go to our minutes and seconds page. And we are at 36. $36.20 is our GMT time. $36.20. Our minutes and seconds for the sun is 9 degrees 050. And our little d correction for 0.8 is going to be 0.5. So now we can use calculator. Okay, we also need to write in our longitude. Our longitude for number 8 is 047, 11.2 west. So if it's west, we're going to be subtracting. We can't subtract 11.2 from 8, so we are going to add 60. We have borrowed that. So we have 357. Gives us an LHA 31057.6. So our LHA is 31057.6. Okay, and that's number 8. Okay, so number 9, we have our date of July 14th, yesterday, and the body we're observing is the sun. Again, they gave us zone time and chronometer time, so we need to convert that to GMT. So our zone time was 13:15. Our zone description they didn't give us, so we need to calculate that. So how do we calculate that? We take our longitude of 154 degrees west, divide that by 15. So 10. 10 is our zone description. We could also look in Bowditch at our zone description table. I think I have it in the Google Classroom as a reference if you want to check that out, but that gives you exactly from what longitude your zone descriptions change. So we have a zone description of plus 10, so our GMT time is actually 23:15, and they told us our chronometer reads 11:16, so we know it's actually 23:16:19, and our chronometer is 1 minute and 12 seconds fast, so we need to subtract that. So we have 19 minus 12 gives us 7, 15, 23. So we have a GMT time, July 14th, 23:15:07. So let's get our GHA and declination. Our GHA on the 14th at 2300 is 163 degrees, 30.2. The declination is north 21 degrees, 29.2. And that is increasing. And our little z at the bottom is 0.4. So now we can go to our minutes and seconds. And we are looking for 15. There we go. 15:07. 15 minutes, 07 seconds. Gives for the sun, gives us a minutes and seconds correction of 3 degrees, 46.8. And then for our minutes, we had 0.4, which gives us a correction of 0.1. So we have a correction of plus 0.1. So now we calculate. Carry the 1. And now we need to put in our DR longitude. And that is west, so we're going to be subtracting. So 17 minus 3 gives us 14. Gives us 0.3 degrees. We have an LHA of 013, 14 minutes, and our declination is north 21 degrees, 29.3 minutes. And that's our answer for number 9. All right, last one. This is number 10. And we have a date of May 11th. And we are observing the sun. They give us a zone time and chronometer, so we need to calculate our GMT and then go to the nautical almanac. So our zone time is 16:24, and our zone description we don't have, but we have our longitude divided by 7.8 gives us a zone description of +8. So again, that was 117 divided by 15 gives us 7.8, and we always go round to the nearest whole number, so that gives us 0.8, or a zone description of +8. So our rough GMT time would be 0, so 2400, 24 on the next day, so that would be the 12th. So that would be on May 12th is our GMT time. Now our chronometer reads 12:24, so we know that's actually 0:24:48. We have a chronometer error of 32 seconds slow, so we need to add that. And so we have GMT time of 25:20, and that is on the 12th. That is our GMT time. So now we can go to the Nautical Almanac. I am at 9, 10, and 11, so I need to switch over to the 12th. And on the 12th, we are looking at 00 and then 25:20. So 00, our GMT is 180:54.6. Our declination is north 18:11.8. We go down to the bottom, we have a little d of 0.6, and I can see we are increasing our declination, so we'll be adding that. And we go to minutes and seconds, I'm looking for 25:20. Here's our 25:20 for the sun, gives us a minute and second correction of 6:20, and our little d was 0.6, so we go to 0.3. Okay, now we can plug in. Our DR longitude was 117.48 west. West, we're going to be subtracting. So our 14.6, we have to add 60, so we'll borrow. And that gives us 74 minus 48 gives me 26. And then I have 186 minus 117 gives me 069 as my LHA. Declination, I have 11.8 plus my 0.3, so I have 12.1, 18 north. And that is our last problem, number 10. So again, we are just getting familiar with our Nautical Almanac, flipping back and forth to all the pages. Again, if you made a mistake somewhere, it's easy to figure it out. If you have the book, you're just adding and subtracting a bunch of times. I did not do the meridian angle and the time diagrams. I have the answers for those in the on the answer sheet, but I decided that time diagrams weren't too necessary. You didn't really know you didn't have to know if it was rising or setting or any of that. That kind of complicated things too much. So so I just decided not to do that. I know it's still on your worksheet and still on the answer sheet, but I'm changing it. Alright, well that's about it, and we will see you next week for diving into the sextant and the sextant corrections we get from the Nautical Almanac. So there is one more section to the Nautical Almanac that we are going to go into next week. Alright, thanks, have a good one.